You're listening to Strange by Nature, your guide to the strange, weird, unbelievable, and improbable wonders of the natural world.
Hello everyone, thanks for being here today. I am Kirk Mona, and I am joined today by Rachel Ginza and Victoria Thompson. We are all professional naturalists who together have scoured the world for weird and wonderful wonders just to please your mammalian brain's desire for novelty. Isn't that nice? Let's do this.
Hey everybody, welcome back to another show. Really excited to be here, and you know what? I'm excited as well because friend of the show and naturalist extraordinaire, Alicia Little, is back this week.
Yay!
Hello.
Hi. They're back. I'm back. So glad to be back.
Always fun to have you back.
On this beautiful Pride month of the year as well.
Yeah, happy to have you here for it.
Oh, it's so exciting.
Rachel's kicking things off this week. I'm excited to hear what you have for us, Rachel.
My topic today, I think, is just really, really cool. And it's something that I don't even know how we haven't covered this yet. And it's wild to me, and I just wanted to talk about it. So today, I am talking about clownfish.
Oh, clownfish.
Oh,
yes.
Clownfish. There's a lot of wild things that happen with clownfish. Okay. So, because obviously most people know what I'm talking about when I say clownfish. 90, probably the entire planet.
We're talking about Nemo. Right?
Yep. Yeah, we're talking about Nemo. If anybody hasn't seen the movie Finding Nemo, have you lived under a rock? Or perhaps a sea anemone?
Yeah, maybe you don't, you're not human. I think it was mandatory all humans watch that film. If you haven't watched it, maybe pause. No, even if you haven't watched it,
I think
you
fine.
know what
right.
Nemo and a clownfish looks like.
Yeah.
They have become ubiquitous.
They're everywhere.
Especially post that film.
Like the like top 3 most iconic tropical fish, hands down.
Absolutely. So, first of all, there's actually quite a few different species of clownfish. There's at least 30 different species of clownfish in the wild. 30.
That's a lot more than I was expecting.
I would not have thought it was that high, yeah.
Right? You don't think of them as,
cool.
Like, you just think of the one little fish from Nemo, and there's like one species, maybe 2, that look like that, but a majority of clownfish don't necessarily look like that. Some of them are the typical orange with white stripes or white bars or whatever. But they could be anywhere from yellow, they can be a red, a black color. Some barely have like any sort of bars.
Ones at aquariums before.
Exactly. And not all of them are even called clownfish.
Well, if you're not called a clownfish, are you a clownfish?
Yes.
We're now welcome to the philosophy podcast.
So they're not
by
just
any
called
other name would swim
clownfish
as well.
They're also called anemone fish.
So
they kind of go back and
because
forth.
They live in anemone.
Yeah. So all 30 of these species have a symbiotic relationship with sea anemones. Some of them are super species specific.
I missed it last time,
but
you said anemone.
Anemone. Anana.
You're this is what you're talking about. How you said there's a thread to your previous topic.
Yes,
it's the anemone thread, right? Yeah,
it's the anemone thread. Yeah. So sea anemones, generally speaking, where clownfish are, found. They're found
around, yeah.
Right. Oh my gosh. They're found in most oceans, and clownfish are only found. So sea anemones can be found in most oceans, including the Atlantic, the Mediterranean, and the Caribbean. But clownfish or anemone fish, they can only be found in the Indian Pacific Oceans. There haven't been any found in the Caribbean, Atlantic, or Mediterranean, which I personally thought was
Interesting.
wild. Like, I would think that with that many different species, you'd find them in all the oceans, I guess. Nope, just those two.
I always find it interesting when like fish have not spread to all the oceans because it's like it's all connected.
Exactly.
And they've had millions of years to spread around, but a lot of fish are very coastal too, with reefs and stuff. And you're not going to go swimming, unlike Nemo. You're not going to go swimming thousands of miles to a new reef. Right. You know, you might go to the next little atoll over or something, but you know, getting from a very isolated reef in one ocean and crossing open ocean with no food or anything like that to another reef, that's the odds are not great. So again, when you stop and think about it, you go, oh, of course, but it might not be something that occurred to you right away, you know?
Exactly. So besides that, it's wild that they live in a sea anemone in the first place. I'm not going to get too into the weeds when it comes to talk about sea anemones because they are wild in it of themselves and should be a topic on their own because sea anemones, they're not plants, but they look like plants, but they're not, but they're not fungus. Anyway. So sea anemones are characterized by having a venomous or poisonous sting. I saw it described as both. I think it is better described as a venomous sting rather than a poisonous sting. And clownfish are one of the very few that are able to live within the tentacles of a sea anemone. There are some other species that can do this, but for the most part, it is mostly just anemone fish or clownfish. And part of this is due to how they go about it. So, like I said, sea anemones are not plants, but they're not fish or anything like that either. So, when moving to a new habitat, clownfish will actually court and like do a specialized dance with the sea anemone.
Huh. Interesting. Really?
Which is wild. And that is partially so okay. So this dance that they do, the clownfish, they generally will be like gently touching the tentacles over a period of like hours or days. And that's to help form a layer of mucus over itself. So it looks like
mucus.
It's dancing. Oh, what a wonderful word, right? Mucus.
Mm-hmm.
And that is to collect a layer of that mucus in order to help protect itself from the stings. So they are very specialized to that particular sea anemone and that species against that particular venom because of this relationship that they build. And it's a really fascinating mutualistic symbiotic relationship that they have with sea anemones. Because not only is a sea anemone, like when you look at it, it looks like the sea anemone is just protecting the clownfish from being eaten by bigger, badder fish, right? But it's more than that.
Right.
The clownfish, its poop, its scat, gets incorporated into, and those nutrients go back into the sea anemone. It also increases more algae in the tissue of the sea anemone so that it allows it to be a little healthier.
Sure, yeah. Makes sense.
Increases the aeration of water. So the movement of water, there's more movement to bring not only more fish potential, because by the way, sea anemones eat fish, which was wild to me. I did not know that.
I didn't actually realize that. Okay.
Right?
Yeah,
this is why
it makes sense, but I never thought about it. Yeah.
So like they, from what I recall, they sting fish and then they curl them into the middle, kind of like how you would imagine a carnivorous plant would. Even though most carnivorous plants don't actually do that. And then they just sort of munch on it, their mouth and their anus is the same hole right in the middle.
That's what we call multi-purpose.
As I said, this is the kind of stuff we talk about at the lunch table. Professional naturalists.
Exactly.
Everything comes down to poop.
Everything comes back to poop. But it allows the aeration of the tentacles to bring more of a flow of water. But the added nutrients from the scat of the anemone fish or clownfish actually also helps the sea anemone. It can allow them to be a little more colorful to bring in other fish.
Ooh. Oh my goodness.
Oh, interesting.
Yeah.
I suppose, yeah.
It's wild. So, and what the clownfish... So it's interesting
that the color is going to attract other fish, like fish to eat?
Yeah, it's going to attract other fish to the sea anemone, for the sea anemone to eat.
Yeah.
It's wild.
I'm just surprised that it being more colorful wouldn't be like a warning to fish to stay away. Like often bright colors are like a warning coloration in nature. Mm-hmm. So it's surprising that they're, actually able to attract fish with that coloration.
Yeah, and that's just a suggestion. It's not necessarily something that is like concrete. This is just a thought that is going around at the moment.
Okay. This is just like a hypothesis that's out there. Okay, okay. Color me skeptical until it's proven then.
Right. And what happens and besides all of that too, the sea anemone also gets protection from parasites and from some predators as well, because clownfish or anemone fish are omnivorous. They don't just eat like zooplankton or algae. They will eat other smaller fish as well. So they'll pick at all of those little bits. And then the clownfish get a nice safe home, the safest nest site that there possibly could be, and protection from predators themselves. So it's a super specific, just an amazing relationship that they have.
Very cool.
Now, speaking of the nesting sites, so clownfish, when they're born, they are all born male. They generally will be in a group, and what happens is they will end up with they have a very strict hierarchy. What happens is the biggest fish, who is the most aggressive, will eventually become female, which is cool. It's just fascinating. And not only that, but they will only mate with the female ends up with her own harem of males, and she'll mate with the most aggressive male, and they'll reproduce through external fertilization. So probably some other male sperm and things will get into the eggs. Wild. But
gotcha.
What happens, which is wild. So what happens is if the female dies or is removed from the group or anything like that, the next largest and most dominant male will then become female, and they'll all move up that rank.
Fascinating.
Wild. And then...
So you're saying in Finding Nemo, if it was just Nemo's dad who was left after the mom disappeared, the dad would have become the mom.
Marlin should have become Marlowe.
Yeah, they didn't cover that in the movie.
They did not cover that in the movie. No. Yeah. But it's really cool, though, because they live to anywhere from about 6 years, I think, in the wild, which is a lot longer than I was expecting. Yeah, it's a long time.
Yeah, not bad. For a little fish.
Yeah, they don't get very big. The biggest ones, I think, were 6-ish inches. But most of them are around 4. Look at a small teacup. They're about the size of a teacup.
Yeah, they're pretty small. They are short and stout. That's a teapot.
That's a teapot, not a teacup.
I still stand by the short and stout part.
Nice try.
I'm curious, Rachel. Do you know? So when they hatch, do they have both types of gonads already, or do they start out with the male gonads and then grow the female gonads later?
From what I saw, is they all have the ability to change their sex, but only do so if they become the dominant female. So, from my understanding and from what I saw, is they have both, but one is more dominant than the other, and it all depends, I think, on like the pheromones,
like what
and
gets activated. Yeah,
exactly. Which super cool. So yeah, they both have both, but if they do change their sex into a female, they will remain a female for the rest of their life.
Oh, very interesting.
So they cannot change back into a male.
Yeah.
Which is pretty cool. Yeah. And
thank you.
Yeah, of course. That's pretty much what I have today. I just really I couldn't believe we hadn't talked about clownfish before.
That it's it's a big world.
That's true. And we don't even stay on
Luckily
this world.
for
We
us.
go everywhere. Yeah, they're really cool. They're really fascinating. I highly recommend everyone go and check out our Instagram first of all, and check out our to see different types of anemone fish or clownfish. But before you do that, hang on and listen, because we've got the amazing, the wonderful Alicia coming up next after the break.
Strange by Nature podcast is brought to you by listeners like you who have joined the Society of Strange, our membership group on over at patreon.com/strangebynature. Society of Strange members can join at one of 3 different membership levels and help support the show, and also get some fun stuff like water bottle stickers or access to super secret content. So a thank you to those who have joined already to help make this podcast possible. If you haven't joined yet, we'll see you soon over at the Society of Strange at patreon.com/strangebynature. See you soon.
All right. Well, after Rachel's very interesting symbiosis topic, I have a really cool topic about another sort of partnership of species, one that may be actually very familiar to many, many of our listeners. And I want to ask you about the question, because I know, Rachel, I know you got a cat fairly recently. Kirk, do you have a cat at home as well?
I do not. I have had cats in the past.
Okay. Then you are probably both very familiar with plant catnip.
Oh, yeah.
Yes.
Mhm.
Yep.
So catnip, scientific name Nepeta cataria, obviously derives its name from
Great name.
cats. It is native to
it's
Southern
wonderful.
Europe, the Middle East, and Central Asia, but it has been spread a lot of places and is considered naturalized, which is basically like it lives here now, but it's not a problem. In North America, New Zealand, and Northern Europe, it is a type of mint. So it's actually totally edible for humans as well, and you can make a lovely minty tea out of it. But it's obviously super known for cats' reactions to it. So cats, if you didn't know already, will go
really something. Yeah.
really wild.
Tell us about it.
They'll go really wild for catnip. You may have seen a cat reacting either to an actual catnip plant or to dried catnip in a toy, by rubbing their face all over it, like tearing it to shreds, rolling around on top of it, puffing it, getting drooly, their eyes dilating, getting really rowdy, or getting the zoomies.
See,
They have
my
a very
cat,
strong
when he
reaction to catnip.
Oh, man. Yeah, my cat, when I brought him home, I was trying to calm him down in the car, so I gave him a little bit of catnip, or like a catnip toy, which was a mistake. But
Yeah.
I got him home and I had like set up the litter boxes and everything. They were all good to go. And he just was rolling it. Thankfully, it was clean, but he rolled in the clean litter like an absolute bizarre weirdo.
Yeah. So, scientists have been noting this weird response that cats have to catnip for a couple centuries. The first recorded report of cat behavior response was actually not to catnip, but to a similar plant called silvervine, which is Actinia polygama, which you'll find in Korea, China, and Japan. But yeah, a Japanese botanist in 1704 and a British botanist in 1759 both wrote extensively about noticing cats' responses to these two plants, not just catnip, but also silvervine, since that was more endemic to Japan. So there's actually not been a lot of research into why cats do this until pretty recently. So the bulk of my information on this topic came from a study from just last year, published in Japan at Iwate University, that was studying what compounds actually cause the cats to react. And
Interesting. All right.
So so cats are they're reacting to a compound called nepentolactone. Actually in catnip, the compound is nepentolactone. In silvervine, it's nepentolactol. You'll probably hear me use both. They used both in the study because they're extremely similar. So the high effect that we see in the cats is actually a reaction. So the nepentolactone goes into their nose, reacts with their olfactory system in their nose, and then tells the brain to release a ton of endorphins. And so they get this huge endorphin dump. Now, endorphins are the feel good chemical in the brain. Like we humans get endorphins, like when you eat a slice of really nice pie, or are hugged really closely by someone you love.
Chocolate cookies baking.
Yep. Oof, yeah. Or you go on like you had a really nice, wonderful hike. Like when you do good stuff, your body's like, yes, that feel good chemical is going to release in the brain. So for cats, they get this endorphin rush when they inhale nepentolactone from catnip and silvervine. And it's actually really interesting. So the reaction that they get is actually kind of similar to when a female cat is in heat. It's a very similar body reaction, and actually,
is when a cat encounters another cat in heat, you mean, or
when the cat itself is in heat. So when a female cat is in estrus, when she's ready to mate, she will be very playful, very much rolling around, very much nuzzling on stuff. If you've ever had an unfixed cat in your house. And the interesting thing is that kittens will only start reacting to catnip when they also have reached sexual maturity.
Huh.
Yeah, so I believe it is following the similar pathways in the brain of like getting to those endorphin pathways that obviously have like a hormonal relationship there as well, which is really interesting. And overall, about 80% of cats will experience this reaction to catnip. They have hypothesized that this is a genetic condition, that those that don't react just by some fluke of genetics, they just don't have the gene that is nepentolactone equals endorphins. But I really want to...
some humans can think cilantro tastes like soap.
Yes.
I can never tell if I have that
but this
gene
study
or not.
was really interesting. I wanted to talk also just a bit about how they did this study. Because obviously, like, cats loving catnip is like just sort of a universally accepted thing. And so they went really above and beyond to like find out what exactly was causing the reaction and prove that it was a like physiological reaction and not just a behavior reaction. So they synthesized nepentolactol from silvervine, and they only ever used just the compounds from the plants, not the plants themselves, to make sure it wasn't to do with like the shape of the plant or how the plant looks or something like that.
Get rid of all the variables.
Exactly. Yep. So they first tested the nipetolactone soaked cloth versus plain cloth with 25 lab cats that were like born and raised to be used as lab animals. Again, that same pattern fell through. 80% reacted very strongly to the nipetolactone. They also visited Tashirojima, which is a famous feral cat island in Japan that a lot of tourists go to, to test it on wild feral cats and got the same results. And then they also did the same test on 1 leopard, 2 lynxes, and 2 jaguars from the OG zoo.
Oh, wow.
Which was very cool. And I actually have a short video that we can share out. They have just a very, very short clip of a cat being exposed to the 2 options and rolling all over the nipetolactol. One of the jaguars being shown the 2 options and rolling all over the nipetolactol. And then they also tested it with domestic dogs and rats. And dogs and rats had 0 reaction whatsoever to the nipetolactol.
Wow.
Right, yeah.
Yeah. And so
because it's not called dog nip.
Exactly,
right.
Yeah. So they even tested the cat's blood before and after exposure and found a marked increase in those beta endorphins in the blood.
Well, there you go.
Something I found hilarious also is they wanted to really be thorough in their study. They gave some cats Narcan, which is an opioid receptor blocker, very famously used to help end overdose in humans. So you may have seen...
If you had too much fentanyl or something.
Exactly, yeah. If you get an overdose of an opioid-type drug, you can use naloxone, brand name Narcan, to help revive someone from that because it binds to the opioid receptors in the brain. And so it makes it so that whatever chemical that they used to get high does not continue to bind to their brain. And so it helps them like wake up and actually start breathing again. So they gave some cats naloxone because it's an opioid receptor blocker. And they showed that any of the cats that had been given naloxone did not react to catnip. They did not react to the nipetolactone compound whatsoever.
Whoa.
Yeah.
So basically is sort of like saying that just a plant, smelling this plant is sort of like, having a powerful opioid.
Yeah.
Like that's...
Yeah, just inhaling the oils from this plant. Yeah. So they went a little further also to describe in the study like what exactly nipetolactol is. So it is a type of compound found in plants called an iridoid. And these typically bind to sugars, and they're typically used for defense against insects. So a lot of critters are going after sugars in a plant. And one really, really annoying bug is, of course, aphids, which literally just latch onto the stem and suck the sugar out of a plant.
Right.
And so iridoids typically will irritate the insides of bugs that are not specially adapted to consume them.
Okay.
So the researchers in this study studying the cat's reaction to catnip went on to start theorizing, like, why has this relationship between cats and catnip developed? And they have heard, sort of anecdotally, of people using catnip as a bug repellent. And so
I've heard of that, actually.
Okay.
Yeah.
They got some of their lab cats and wiped them down with nipetolactol soaked rags and anesthetized them and then put them in chambers with mosquitoes.
Oh,
that's so sad.
Okay.
Yeah, the cats are fine. They're fine afterwards. But they found that the ones that were rubbed down with nipetolactol had only half as many mosquitoes landing on them.
Wow.
So a big drop.
If you roll around in this thing that smells good, makes you feel good, it has a side benefit of also keeping the bugs away.
So they theorize that this relationship may have developed as a natural bug repellent, especially because of the behavior of cats specifically as stalking hunters. They're doing a lot of sitting extremely still in tall grass
Right.
or in treetops or other places, shady places where bugs are going to be landing on them constantly. And so they don't want to have to be swatting those away and giving away their position. So this endorphin response encourages them to get covered in catnip, and then that helps keep them a little bit healthier.
Well, and you can see how even if that was a completely random genetic mutation, if it's beneficial, it's going to spread like wildfire through the population.
Yeah, and the fact that it happens across house cats and big cats means that it happened quite a long time ago before those species
long ago,
diverged.
Fascinating.
Cool.
But yeah, so that's
All right,
cats
Alicia.
and catnip.
Thank you, Alicia.
And I will absolutely be sharing the video and also the link to the actual study because there's some really, really fun graphics in the study with adorable little outlines of cats. And yeah, it's great.
Oh my gosh.
We will
Thank you.
put a link to that on social media, but also in the show notes.
Yeah. Right.
Well, that has been cats and catnip. So I'm hoping that Kirk can keep up our pattern and have a double species topic like the rest of us, but we shall see after the break.
Yes, we shall. Well, your wish, Alicia, is about to come true because
What?
I do have a sort of double species topic here, though probably not in a way you're going to like.
Oh.
I'm just going to put that out there. With summer now in full swing, I have a horrifying and strange story for you that hints at how much of the world we can't perceive. So this has always been of interest to me. As humans, we are incredibly biased to assume that like what we can hear and
Kirk.
see and smell. Yeah, Rachel?
Oh no. Are you gonna
What?
break our brains again?
I mean, I'll try.
Oh no.
As humans, we are incredibly biased to assume that like what we can see and hear and smell and taste are like the most important things. And indeed, they intend to be important to us, but there are things going on that we can't naturally perceive. Like we can't feel or see radiation or X-rays or radio waves, for example. We can't even see ultraviolet light, which other animals can. We've talked about that, I think, just a few episodes back. So as a naturalist, I'm just interested in the things that we can't perceive as the things that we can perceive. And a study came across my desk this winter, and I've been saving it for summer because it seemed more appropriate, and you'll see why in a second.
Oh no.
Well, I'll just tell you right now. This study involves mosquitoes.
Ah.
It's about mosquitoes.
The bugs
And
are so bad right now.
That would have been, yeah, it's, I don't know how it is for everybody else listening, but where we are right now, the mosquitoes, they've been pretty tame for the past couple of years because we've been in a drought. And this spring was wet, and we are paying for it dearly. So we can certainly see mosquitoes, and they can see us, but seeing us is not the primary way they locate us. We've talked on the show about how mosquitoes are more attracted to people of certain blood types, which is fascinating and strange. We also know that mosquitoes are drawn to the carbon dioxide we exhale, so they're basically like smelling their way to us. Keep in mind, though, that carbon dioxide is odorless, so that alone is super weird, and I could rightly just do a topic on that alone. How on earth do they detect a colorless, odorless gas, which is very impressive. But I have something even stranger to share about mosquitoes locating humans.
Sure.
And it sort of involves that, like, things that we can't normally perceive, which is why I find it so strange and interesting. So in order to think about what it is, we need to think about mosquitoes themselves for a minute. There are lots of reasons to hate mosquitoes. The female ones, at least, suck your blood, which they have to have in order to make eggs. And it's their saliva that we have an allergic reaction to that makes us itch. So my left ankle actually itches literally right now as we're recording. It's driving me crazy, and it's just one bite.
Yep.
But those first ones of the year are always the worst because your body's not really used to it yet. Where we record, here in Minnesota, and indeed a lot of areas where our listeners are, mosquitoes are they're an annoyance, right? They make you itch, which is unpleasant, but it isn't going to make you like ill. That isn't true everywhere, though. I'll tell you, I don't know if you guys are aware of this, half of our audience is outside of the United States. And in many parts of the world, Mosquitoes are very, very bad news.
Oh, yeah.
There are serious diseases spread by mosquitoes. Malaria is a famous one, but we also have dengue, yellow fever, Zika, West Nile, and a handful of others. As the planet warms, more and more of these diseases are making their way to North America. Some of them have already showed up in more southern parts of the U.S. So we got that to look forward to.
Yay.
Now, in order for these diseases that are associated with mosquitoes to spread, the mosquitoes need to find you and infect you with that. They're not trying to, it just happens incidentally when they feed on you. But mosquitoes are pretty good at finding humans naturally. But what if the virus gave them a little help?
What?
So 2 of these diseases, Zika and dengue, are caused by viruses that are essentially in the same family of viruses. And a team of researchers reported last summer that these viruses both have an amazing evolutionary adaptation. Now, one of the ways mosquitoes smell their way to their hosts is apparently by sniffing around for a molecule called acetophenone. And this is basically like a naturally occurring smell given off by a bacillus bacteria that exist on our skin. And bacillus is super common. There's a number of varieties, like anthrax being a very famous bacillus bacteria, but there are much less harmful varieties as well. There's likely some hanging out on, a good portion of the skin of our audience at this moment, just hanging out very small amounts, not causing an infection, but just, being there as part of the normal small part of your skin flora. So a bacillus infection is not good though on your skin, and your skin wants to keep this bacteria in check. And it naturally does this by creating an antibacterial peptide. And what these researchers found out was that if you infect mice with Zika virus or dengue virus, the skin of those mice creates less of the antimicrobial peptide. And with less of the bacteria fighting peptide, the bacillus is able to grow more quickly on your skin, and thus you give off more of the acetophenone smell.
Oh my God, so you become stinkier to the mosquitoes.
Yes, exactly. And that's such a great advantage of the virus. The virus needs to reproduce in your blood, and then it needs to get back out to spread. And the only way it can do that is by getting into a mosquito. So it would seem that some of the mosquito-borne viruses actually change your body to make you attract more mosquitoes, and this in turn increases the odds of you getting bitten and spreading the virus to other hosts. So that is just mind-blowing.
That's so insane.
I don't like that.
That viruses are having that effect on us, and clearly on other animals as well. It's not just humans. I know they tested it on mice, because mice also get this same, is very similar to humans in that regard. The research I was talking about today was actually on Zika and dengue, but recent research within the last, I was seeing some from like 2018 or so, was showing that the same thing happens with malaria. And malaria also changed the smell of humans. Interestingly, in a completely different way, totally different mechanism, but also makes people with malaria easier for the mosquitoes to detect. They actually didn't just test this on like mice. They would actually test humans who were infected with malaria and like use them as like against a control group and go, yeah, no, these people actually have more mosquitoes landing on them than people who don't have malaria. So fascinating. That's my whole topic. It's pretty short and sweet.
That is so
it's just
wild.
some new research coming out showing that being infected with a virus could actually make you easier to find by mosquitoes.
Awful. Terrible
which
news.
Just sort of blows my mind. And this is the thing going on that, like I said at the top, it's invisible to us. I couldn't go, oh, Rachel, you smell today like you might have Zika virus, but that is something that is fundamentally happening and in changing how we interact with nature and how nature interacts with us.
That's wild.
It's very, very wild.
That's such a crazy adaptation though too of because we have learned or had a great front seat in the last couple of years of how fast viruses can evolve and change.
Oh yeah.
Mm-hmm.
But because their life cycle is just so much faster.
Had that lesson, but yeah.
But that is such a crazy method to come up with that it's so
and it's trial, like so much of it's trial and error. It's
yeah,
just like,
right. It's just random
probably-
chance. Like, oh yeah, this works
Yep.
better. And so then they all start doing it because that's what survives. That's so wild.
Yep, exactly.
Oh.
And the fact that multiple viruses have done
Yeah.
this,
I think it helps that
but
they're in the
happen
same.
to target different systems within the body that create smell.
Yeah, I think it does
so
help
cool.
that they're in.
And granted-
they're in the same family, right?
Yeah. So Zika and dengue, and some other ones as well, are in the same sort of group or family, whatever you want to call it, of viruses. And so there's probably a common lineage, is why those are all able to do that. But like malaria, again, not as closely related, other than the fact that it's a mosquito-borne virus. And so it has a totally different mechanism. And it makes you realize that there's probably a lot of things like this going on out there. Like, are there, and I want to be perfectly clear, this is something I'm just imagining on the spot, but one could imagine that there might be a virus that when you get it, it affects your brain and makes you more social, which makes you more likely to spread it. There's all these things. There definitely are viruses that make animals want to bite other animals because it's in the saliva and then it passes on. We talked about examples of that on the show. I think like rabies will do that. They'll make animals rabid and want to bite other animals, and it's in the saliva and boom, it passes on. So like this is a pattern we see, but the smell one,
that's wild.
Is just that was
And
new to me.
It's such a
Very
subtle thing too, because like wanting to bite
you'd have no
something
idea.
else is a big thing, or like with horsehair worms make crickets want to like drown themselves. But
yep.
We're just gonna change the bacillus concentration on your skin so you're just a little stinkier for the mosquitoes.
Right.
Yeah. Well,
Fascinating.
the other thing too is like smell is hard to like be able to like differentiate, and like you have to get close to ish.
I didn't see any information on like how far away they were smelling this, but there was research that's been done now that we know this. Is there some like sprays or things you could do like to mask that smell, or could you basically give people medicine to treat skin infections, which would then actually reduce the spread of disease in these areas because it would make it harder for the mosquitoes to find them. I mean, so there's some really interesting stuff that might come out of this initial research, which is pretty exciting.
Yeah.
I do need to share some of my sources this week. One of them was this main article here, a volatile from the skin microbiota of flavivirus infected hosts promotes mosquito attractiveness. Which was in the journal Cell. That was the main research I was talking about. So flavivirus, or flavivirus. Yeah, flavivirus. That's the group that had Zika and dengue. If you're really interested in the whole malaria piece, there was an article in our favorite journal, PNAS, called Plasmodium Associated Changes in Human Odor Attract Mosquitoes. So pretty wild stuff.
Awesome. Thanks,
Very cool.
Kirk.
But you know what? That's you're welcome. Wear your bug spray, get outside, enjoy the summer, and we'll just see everybody next week.
Yeah. See y'all next week, everybody. Bye.
Bye-bye.
Thanks everyone for listening to today's show. Be sure to subscribe. New episodes drop every Wednesday, and we love sharing this strange world with all of our listeners. If you would be so kind as to leave us a 5-star review, that would be great. It lets other lovers of the strange discover the show. You can reach out to us on social media by searching for Strange by Nature Podcast on Twitter, Facebook, and Instagram. You can send us an email as well. Our address is contact@strangebynaturepodcast.com. If you want more information about the show, you can also check out our website, which is strangebynaturepodcast.com. Until next week, get outside, stay curious, and embrace the strange.